Welcome to another video. Let's solve these quartic equations. But these questions, if we are trying to expand this in 4 times, it will take time. And here is a short method of solving this. We are going to let y equals to s plus 5. And if you wish, you can also take x plus 3 as y. Anyone. We make x the subject of the formula, whereby we have x equals to y minus 5. Since we have let this, we are going to replace it in the real equation as y to the power of 4 minus bracket, and x is y minus 5 and plus 3 raised to power of 4 equals to negative 16. The next thing is we are going to have y to the power of 4 minus, if you subtract these two, we have y minus 2, everything raised to the power of 4 equals to negative 16. Then, we want to expand this as well, but we don't have to open the bracket. Let's apply the Pascal triangle coefficient as 1, 1, 1, 1, 2, 1. Then we have 1, 3, here is 3, 1. Okay, so this is 3. Then we have 1, 4, 6, 4, and 1. So we are trying to be adding this together. For this one is when the power is 0, so we apply the first one. The second one is when the power is 1, these 2, 3, and 4, up to the... So then we are going to apply the last one since it suits the given equation here. If you have y to the power of 4 minus, so we are going to create a larger bracket, and so if y raised to the power of 4, definitely minus 2 will be raised to the power of 0, then plus y to the power of 3 and negative 2 raised to the power of 1. So what I did here is, if you add the power of these two together, it must be equivalent to 4. So if 1 increase, 1 decrease. Then plus y to the power of 2, then minus 2, everything raised to the power of 2, plus y to the power of 1, minus 2 raised to the power 3, plus y raised to the power 0, minus 2 raised to the power of 4, all bracket, equals to minus 16. So I've not applied the coefficient. Let's see y raised to the power 4 minus. So if we try to simplify this, any number raised to the power 0 here is 1, then whereby we have y raised to the power 4, and here becomes minus y raised to the power 3 plus 4y raised to the power 2 minus 8y, and y raised to the power 0 is 1, so we have plus 2 raised to the power of 4, that is 16. Everything equals to negative 16. Alright, so we are going to apply the last one with the power of 4, and we start placing it. Here we have y raised to the power 4 minus. So the first term here is having 1 as the coefficient, so we place it, and here we have y raised to the power 4 minus. So the second term is having coefficient of 4, we multiply it, that is 8, y raised to the power 3. So followed by the next term, which is 6 multiplied by 4, that is 24, y raised to the power of 2. Then minus, so the fourth term is 32y plus the last term, which is 1, and 1 multiplied by 16, 16. Everything equals to negative 16. And by opening the bracket here, we are going to have y to the power of 4. If you open this, we have minus y raised to the power 4 plus 8y raised to the power 3 minus 24 y raised to the power 2 plus 32 y minus 16 equals to negative 16. So from this last line, some have cancelled each other, and we have plus there, so that is why this one is appearing plus, appearing negative. Then if these two cancelled and these also cancelled, we are going to have 8y raised to power 3 minus 24y square plus 32y equals to 0. And here comes the cubic equations. So if we take out 8y, which is common to them, we have y raised to power 2 minus 3y plus 4. Everything equals to 0. So try to expand this, we get the above. So from this quadratic expression, we are going to have 8y equals to 0, or y raised to power 2 minus 3y plus 4, everything equals to 0. So y equals to 0 here, but I've left something above as x equals to y minus 5. So we are going to replace it since we are looking for x, not y. Then we have y minus 5 and x equals to minus 5. Here is the first root of the equation above. And let's see how to deal with this. If this is the sum, we have this as the product, but this is not factorizable, and not all the time we'll be using the quadratic formula. Let's do something different. If you have 3 divided by 2 and we raise it to power 2, okay, so I'm going to be adding this and subtract it in this equation. Here we have y squared minus 3y, and if you add plus, if you're trying to multiply this thing 2 times, you're going to have 9 divided by 4. And we subtract 9 divided by 4 as well, and we add plus 4, everything equals to 0. So we are still referring back to the real equation. So we cancel this to get the real equation. But let me combine all these 3 terms together. So if we combine this, we are going to have y minus 3 divided by 2, everything raised to power of 2. So if you try to expand this, you get it. Y for this for these two, we are going to have we are going to have plus. Okay, so we're trying to find the LCM. So we multiply 4 by 4, that is 16, minus 9, that is 7. Then we are going to have equals to 0. Then we transfer 7 divided by 4 to other side. Hereby we have y. We are going to have y minus 3 divided by 2, everything raised to power of 2, equals to minus 7 divided by 4. It changes to negative when it equals to. Here, by taking the square root of both sides, we are going to have plus and minus the root of minus 7 divided by the root of 4. So these two separate. And root of this minus 7 is a complex root, which results into this. And the value for this one is root of 7i. Okay, and if you have y equals to 3 divided by 2, we take this one to the other side, plus or minus uh, root of 7i divided by 2, because 4 is a perfect square. So we hereby have 3 plus or minus root 7i divided by 2. But here is not the final answer. We also recall from this, and we are going to replace it here. If you have x plus 5, we let it equals to y from the above. Then we replace y with this, what we get for the value of y. Here we have x plus 5 equals to, instead of y, we have 3 plus or minus root of 7i divided by 2. But how can we get the x only? If you cross multiply, okay, we are going to have 2x plus 10 equals to 3 plus minus root of 7i. By taking 10 to other side, we have 2x equals to, here becomes minus 7 plus or minus root of 7i. and we divide 2 by 2. X equals to minus 7 plus or minus the root of 7i, everything divided by 2. And here comes to the third and the second and the third root for the equations above. You see that this equation is not a quartic, it is a cubic equation. Thanks for watching, and don't forget to subscribe and never stop learning.